after releasing 2 videos about coding in assembly, I received a lot of comments, and what I really loved about them is that there were actually many interesting discussions to be had, as well as people just sharing their own experience and programming anecdotes. I mean, it was really amazing to have become a platform for so many people around the world. Imagine
only programs at the edge of computational capacity, or at least math, is rarely useful outside of niche scenarios. A C compiler will almost always fragment. This is why I much prefer to get C or C++. And super annoying scalars have one space for any function per second.
Alright, fine. Let's try this C language that you've been recommending. I mean, if we will be comparing proper low-level compiled languages against assembly, I could go with Pascal, which I'm more familiar with. Hell, I've never wrote even a single program in C, but no one using Pascal in 2026 means it's no longer feasible for near-personal projects. I should avoid it at all costs and blindly follow what people tell me to because it's just more popular. Now, I did a little bit of research, and there actually appeared to be a lot of options when it comes to choosing your version of C. For example, C++ seems to be more talked about, and I see why. I mean, it's C+1, so it's even more C than before. I was almost compelled to go with it until I saw that it was from the years 1979 to 1985, and that's way too old for today's standards. And even if I wanted object-oriented programming C, I would just go for Objective-C, because if it has objective in the name, then it's gotta be more focused on it and therefore implements it better. I also saw that there was a C++, which was newer than C++, but as far as I understand, having less C is considered bad practice, and I wouldn't want any of that in my code. Then the next most popular one was C#. It's actually the one that Microsoft seems to advertise most nowadays. I mean, it's on MSDN and everything. It seemed very good at first, with it being a semitone higher than C, hence why it was labeled high level, and the core being called system, just like in Free Pascal. But, well, if it's only a semitone higher, isn't it just C++ again? And if I wanted to go high level, I would have probably picked D or E, and even then, I myself haven't been high in a long time, so it probably wouldn't suit me as much. I also took a brief look at handheld C, but quickly dismissed it as untrustworthy, because while it stated it was still high level, there's historical evidence that shows handheld C was instead actually lower than modern C, because his A was pitched at 422.5 Hz instead of the modern 440 Hz. Seems about right. There was also Holy See, but even though I'm in Italy, I'm still pretty far away from the Vatican to use it properly. Then I also remembered about Nidot's ASM-C, which seemed like a perfect blend between the two worlds, but ultimately it wasn't mentioned on the list of C family programming languages Wikipedia page, and just didn't seem very popular, so sadly I had to abandon that idea. And after digging long enough, I finally found the version most people were probably pointing towards, that being just a regular, bland C. It didn't seem right with it being from the 70s, but at least its first release beat Pascal by like 2 years. So I went to download the compiler on the official website, and it showed me options for either an IEC or an ISO. I didn't know what an IEC file was, so I went with the ISO. And then it asked me to pay 227 CHFs, which I read was congestive heart failure. I didn't have that many hearts to spare for 227 of them to fail, so I had to look for alternatives. Thankfully, I managed to find the Compilers tab on the Tools page of the website, which had so many to choose from I started to feel dizzy. I could accept that Hannah used it, but I didn't think it would be that old. After looking at all the options I had before me but knew next to nothing about, I decided to go with GCC, as it felt like that would probably be best suited for me. I actually saw a lot of people use MSVC, but it appeared that the only way to get it was to install a bunch of bloatware, so I bailed out to spare my poor 256GB SSD. The GCC page blasted me with its light-themed glory, but fortunately my eyes weren't as weak as those of my viewers, so I got out unscathed. I then learned that GCC was actually something I've already had installed on my Linux machine, so that made it even better. but for fair comparison, I'd want to compile to Windows. A quick Google search led me to find that people were recommending to get some Minge, which would have been impossible as I was already a Linux user. On the contrary, people were saying that my Linux distro itself could find me an apt Minge, so I tried it and it miraculously worked. In fact, there were so many, I didn't know which one to choose. I decided to install the most basic one, but it brought all of its friends, so now I had more than a gigabyte worth of Minge on my machine. I had some trouble locating the one that I needed after it was installed, but then I figured out it was really as simple as x86_64-w64-mingv32-gcc-win32. So I began my work by writing a simple test starting point. I looked up a way to print something into the console, and pretty much all of the examples made you include STDs into the code. I, however, wanted a clean and healthy Minge, so at first I decided not to use that and to write my own print function using the Win API. I then remembered that for writing into the console using Win API, you'd still need to get STD, so I guess I still failed in the end. Then it all amounted to simply calling the same functions and setting the same fields like with assembly, just in a different environment, only maybe not as deconstructed. Okay, maybe not as simple, as everything suddenly was a lot more strict and required me to remember all the typization, which of course included typed pointers, amongst other things, even when functionally probably wouldn't have been any different with me just having the idea of what I want to do byte-wise. And my Minge appeared to use an older C standard where bools were still part of STDs, so I ended up using Windows booleans instead. But at least now I could declare local stack variables in the middle of a function and immediately assign them, so that's pretty nice, I guess. There were only a couple problems with the linker not finding implementations for the functions, which were solved pretty easily by adding the respective options to the command line. So now the OpenGL context was nice and ready, ignoring the artifacts at the sites, which I thought were the product of Wine's horrid DPI scaling, so I went on to try to make my program DPI aware based on how it was done in boilerplate 3D, but that didn't work because the function was actually in the wrong place there. But what had completely flown over my head was that the artifacts and screen color were not changing because I simply forgot that for that to happen, the screen actually needs to be cleared. Add helping debug my assembly framework to the list of benefits that C has brought me. I decided to remake the boilerplate 3D soft body demo. It was the longest of them all, but still not as complicated. I began with re-implementing the importers, first of all creating the vector3 and vector2 structures to use when storing mesh data. I then realized that to not specify struct every time near their symbolic identifiers, I would need to specify that it's a type def, as if I wanted anything other than a type definition. With the importers kind of re-implemented, loading the model and texture takes some time, but it's not a repeated process, so I didn't bother too much. The next step would be rendering. First I set up a projection, translated the model view matrix a bit, and finally drew the mesh. Well, I forgot about a bunch of things and made some mistakes, but also the texture loading didn't work at all because of cryptic array pointer dereferencing. I fixed the texture importing and the model misbehaved due to my stupidity when calling getFileSize. Guess typization didn't save me this time. And finally everything worked. I then tried porting the original assembly code, re-implemented all the basic stuff like delta calculation, input processing. When it came to physics, I kind of gave up and brute forced a slightly different implementation. I then went on to re-implement multi-sampled anti-aliasing with the WGL choose pixel format ARB extension, which went quite alright, save for a few pointer type wrestling cases. The only thing left to add would be an FPS counter, and then we could compare our result with the boilerplate 3D counterpart. It wouldn't be a very exact and fair comparison, as what I wrote in C is a more standalone, isolated project, while the demo for boilerplate 3D uses, well, boilerplate 3D, which is a framework that's supposed to be tailored for best generalization and compatibility practices, but the demo also wasn't written with too much optimization in mind, as I've noticed from rewriting its code in C, and the C code would have been explicitly tailored for the needs of my project, so it did not account for creating a comfortable interface and generalization, and focused more on the particular implementation. At the end of the day, the boilerplate 3D demo reached a stable 60 FPS with vertical synchronization enabled, and hovered somewhere just below 1000 with it disabled and when recording. The final executable weight amounted to about 32 kilobytes and the model was unoptimized, so it took about 1.4 megabytes. The executable for the C program instead was 135 kilobytes, which isn't a substantial increase, and the FPS with VSync enabled also reached a stable 60, but with it disabled... almost the same thing? Oh wait, I forgot to turn on compile optimization.